Have you ever wondered if we could turn the most destructive objects in the universe into our personal power plants? Today, we're diving into one of the wildest ideas in physics that could literally power our entire civilization for billions of years. But here's the catch. One tiny mistake, and we'd all become cosmic spaghetti. Welcome back to another mind-bending episode where we explore the question, can we actually turn black holes into energy sources without accidentally destroying everything we've ever loved? Now, before you start picturing scientists casually tossing solar panels into the nearest black hole, let me tell you something that'll blow your mind. The energy we're talking about here isn't just impressive, it's almost incomprehensibly massive. A single black hole could theoretically provide more power than our sun will produce in its entire 10 billion year lifetime. But naturally, because the universe loves irony, the same thing that makes black holes incredible energy sources also makes them terrifyingly dangerous to even think about approaching. Let's start with the basics, because honestly, black holes are already weird enough without jumping straight into the science fiction territory. Picture the most extreme object you can imagine, something so dense that it warps space and time around it like a bowling ball on a trampoline. Except the trampoline is reality itself, and the bowling ball weighs as much as several suns. That's your average stellar black hole, and they're actually the small ones in this cosmic horror story. The key to understanding how we might extract energy from these monsters lies in something called the ergosphere. Now, don't let that fancy name scare you. Think of it as the black hole's personal dance floor where space itself gets dragged around in circles. This happens because most black holes spin, and when something that massive rotates, it literally grabs onto the fabric of space-time and forces everything nearby to spin along with it. It's like being caught in the ultimate cosmic whirlpool, except instead of water, you're dealing with twisted reality. Here's where things get interesting from an energy perspective. Inside this ergosphere, there's actually a way to steal energy from the black hole itself. The process is called the Penrose mechanism, named after physicist Roger Penrose, who probably had the most epic eureka moment in scientific history when he figured this out. The basic idea is surprisingly elegant in its cosmic audacity. You send something into the ergosphere, split it in half, throw one piece into the black hole, and somehow the other piece comes flying back out with more energy than you started with. I know what you're thinking. This sounds like the universe's most dangerous magic trick, and you're absolutely right. The devil is entirely in the details, and those details involve precision that would make a Swiss watchmaker weep. But before we get into why this is harder than teaching a cat to do calculus, let's talk about just how much energy we're potentially dealing with here. When I say black holes contain ridiculous amounts of energy, I'm talking about numbers that break most people's brains. A black hole with the mass of our sun could theoretically provide enough energy to power human civilization at current consumption levels for trillions of years. Not millions, not billions, trillions. That's longer than the current age of the universe by a factor of about 100. We're essentially talking about an energy source that could outlast the death of most stars in the galaxy. But here's where reality comes crashing back into our cosmic daydreaming. Actually harvesting this energy requires us to build infrastructure around objects that exist in the most extreme environments in the known universe. We're talking about regions where gravity is so intense that time itself runs slower, where tidal forces could stretch you into a human noodle faster than you can say, oops, and where the smallest miscalculation could result in your entire harvesting apparatus disappearing beyond the event horizon, never to be seen again. The most promising approach involves something called a Dyson sphere, but not the regular kind you might have heard about. Instead of surrounding a star, we'd build a massive structure around the black hole, designed to capture and redirect the energy we extract using the Penrose process. Imagine constructing the ultimate cosmic power plant in a region of space where the laws of physics become so extreme that your engineering textbooks might as well be written in ancient Sumerian. The engineering challenges alone are enough to give Stephen Hawking nightmares from beyond the grave. First, You need materials that can withstand gravitational forces that would crumple diamonds like tissue paper. Then you need a way to maintain stable orbits around an object that's constantly trying to drag everything into oblivion. Oh, and let's not forget that you need to do all of this while dealing with radiation levels that would make Chernobyl look like a pleasant vacation destination. But wait, there's more cosmic horror to consider. Black holes don't just sit there politely waiting for us to harvest their energy. Many of them are surrounded by accretion disks, swirling clouds of superheated matter that glow brighter than entire galaxies and shoot jets of particles at near light speed across thousands of light years. It's like trying to set up a delicate scientific experiment next to an active volcano that's also somehow managed to become a particle accelerator and a death ray all at the same time. Despite all these terrifying obstacles, some scientists think we might actually have a shot at making this work, though probably not anytime soon. The key is starting small and working our way up. Instead of immediately trying to harness supermassive black holes that weigh billions of times more than our sun, we could potentially start with smaller black holes or even try to create artificial ones. Yes, you heard that right. Some researchers have seriously proposed creating our own black holes for energy harvesting. These wouldn't be the massive stellar remnants we see naturally occurring in space, but tiny microscopic black holes that would evaporate through Hawking radiation in controlled ways. It's like having a pet black hole that slowly dissolves while providing power. Except if you mess up the feeding schedule, reality might implode. The beauty of artificial micro black holes is that they solve several problems at once. They're small enough that we could theoretically contain them using electromagnetic fields. They evaporate at predictable rates, giving us controlled energy output. And if something goes wrong, they disappear relatively quickly instead of growing into planet-eating monsters. Of course, the technology to create and contain such objects is currently about as advanced as our ability to fold space and time into paper airplanes. But let's say we somehow solve all the technical challenges and build our black hole power plant. What could we actually do with that much energy? We're talking about power levels that could literally reshape our entire relationship with the universe. Interstellar travel would become routine rather than the stuff of science fiction. We could power massive space habitats, terraform entire worlds, or even undertake projects that seem completely impossible today, like moving planets or building artificial solar systems. The energy density is so incredible that a successful black hole harvesting operation could make every other power source look like a hand-cranked generator. Nuclear fusion, solar panels, wind farms, they'd all become quaint historical curiosities like steam engines or telegraph systems. We'd be working with energy sources that operate on the same scale as the fundamental forces that govern reality itself. However, there's a darker side to this cosmic power fantasy that we need to address. With great power comes great potential for catastrophic screw-ups, and when you're dealing with black holes, catastrophic doesn't begin to cover it. A malfunction in a black hole power plant wouldn't just cause a blackout. It could potentially create gravitational anomalies that affect entire solar systems. Imagine if something went wrong and our carefully controlled energy extraction process accidentally caused the black hole to grow instead of shrink. We'd essentially be feeding cosmic steroids to an object that already specializes in consuming everything around it. The result would be like giving a great white shark both infinite hunger and the ability to teleport directly to your location. There's also the question of who gets to control such incredible power sources. Throughout human history, control over energy resources has shaped the rise and fall of civilizations. When we're talking about energy sources that could power galactic civilizations, the political and social implications become almost as mind-bending as the physics involved. But perhaps the most fascinating aspect of black hole energy harvesting is what it represents for our species' relationship with the universe. For most of human history, we've been at the mercy of natural forces, storms, earthquakes, floods, and cosmic events that could wipe us out without notice. The ability to harness black holes would represent a fundamental shift from being victims of cosmic forces to becoming masters of them. We'd be taking objects that represent the ultimate expression of gravitational destruction and turning them into tools for creation and expansion. It's the ultimate cosmic recycling program, taking the universe's garbage disposals and converting them into power plants. There's something beautifully poetic about the idea of using the most destructive objects in existence to fuel humanity's greatest achievements. Of course, we're still probably centuries away from even attempting something this ambitious. Current technology can barely get us to Mars reliably, let alone build megastructures around black holes. But the fact that scientists are seriously studying these possibilities shows how far our understanding of the universe has come. The mathematics work out, the physics make sense, and the potential rewards are literally astronomical. All we need to do is solve a few tiny problems, like developing materials science that currently exists only in theoretical papers, mastering gravitational engineering that makes rocket science look like finger painting, and learning to work safely in environments where the fundamental constants of reality start behaving like suggestions rather than laws. So can we turn black holes into energy sources without dying in the process? The honest answer is maybe eventually, if we're incredibly clever and ridiculously careful. The technology required is so far beyond our current capabilities that we can't even properly estimate how long it might take to develop. But the potential payoff is so enormous that it's worth taking seriously as a long-term goal for our species. In the meantime, we'll keep studying black holes from a safe distance, developing better theoretical models, and occasionally having nightmares about what happens when cosmic engineering projects go wrong. Because while the idea of harnessing black holes for energy is incredibly exciting, it's also a sobering reminder that in the universe, the line between incredible power source and civilization-ending catastrophe can be thinner than the event horizon itself. What do you think? Are we crazy enough as a species to actually attempt something this ambitious? Or should we stick to more sensible energy sources, like fusion reactors that only occasionally threaten to vaporize small cities? Let me know in the comments, and remember, the universe is under no obligation to make sense, but it's definitely under obligation to keep us entertained with increasingly ridiculous possibilities.